Hello guys, welcome to our YouTube channel. In our series, in the previous video, we have understood the basics of inferential statistics, right? Today, what we will do, we will deep dive and we'll study how to master inferential statistic through data summarization. So today we will understand three basic concepts which are called mean, median and mode. Okay. Before diving into the video, let's understand one very simple scenario. Imagine you run a business and you want to understand your customers' income, or maybe you want to analyze cricket score, or maybe you want to track your daily step on your smartwatch. You cannot make sense of 100 or 1000 of number unless you summarize them, right? That summary, that heartbeat of data comes from three basics but very powerful measures, which is called mean, median and mode. Okay, it is called mean, median and mode. These three are the foundation of all advanced statistic analysis and machine learning. So in this video, what we will do, we will try to deep dive into what they mean, how to calculate them, when to use them, and most importantly, how they connect to the real world. Okay, without doing any further delay, let's go deep into the summary of these three core concept of inferential statistics. Okay, now before we jumping into the context and I start giving example, have you asked this question to yourself that why we need statistics? So before we start, let's remember stats is how we turn data into decisions. Okay, if raw data is the food, then descriptive stats means mean, median and mode, and these three are ingredient that make the recipe understandable, right? Without them, everything else from regression to neural network is just math without meaning. Okay, so let's try to understand what statistic is. So as it is written over there, stat is very simple transformation. It transforms the raw data into meaningful decisions, right? What does that mean? It describes what your data says, like average mark of the class. Okay, so stat transform first of all raw data into meaningful insight, and descriptive stat like mean, median and mode summarize large data set. What they do, they try to infer something about the entire population from a sample. Okay, in this video we'll focus more on these three things: mean, median and mode. Okay, but we'll connect them into inference in the later parts. Okay, now what we did, we moved from here to here. Let's move from here to here. Descriptive stats describe data. Inferential statistic infer about population from a sample. Okay, so when you hear about descriptive statistic, the first word, which is descriptive, tells you about the description of the data. Okay, and then the inferential statistics give you or tell you the inference about the data or about a population. What is population? Just imagine, I'll give you example. Before election, you might have seen a lot of exit polls, right? So do you think those news channels do the survey of entire population? No, they pick random sample of different segment of that population. They try to create a sample of it, and based on that sample, they infer some kind of result. So when I say infer, the inferential statistic comes into the picture. Rather than taking interview of the whole population of a state, what they do, they just pick random sample of the population and try to infer some information from that sample, and that sample becomes or creates some kind of logic for the entire population. Okay, so this presentation, now let's move here from here to here. This presentation focuses on descriptive statistic summary like mean, median and mode. Okay, and it summarizes data into essential. Summarizing data is essential to grasp larger volume of number. Means if you cannot go to the entire population, if you can go to the inferential and descriptive statistics, understand about mean, median and mode, then you can easily understand about a large population, or I can say the large data. Correct? I hope you understand my point. Let's move to the next slide. Let's understand mean first. This slide might take some time, but let's understand the mean first. So mean is a very simple but very powerful presentation of the entire data. Mean is basically the sum of all the value, okay, the sum of all the value and the number of all the values. It represents the center balance point of data in the data set. Okay, what can be the example? Just think. Just take a very simple example that one student scores 60 mark, another 70, then 80, then 90, and then 100. What will be the total of it? The total of it will be of 5 students' marks will be 400. So how many students are there? 1, 2, 3, 4 and 5. And how much marks they have obtained? 400. So overall marks they obtained 400 divided by the number of student 5. The total, the mean would be 80, right? This is how the mean is calculated. The second example is, again you can see the sales in a shop is 800, 1100, 1200, 900 and 11,000. So the mean sales value is 2980. But do you think this is right? Because what you are doing, the most of the sale which you are doing is in the range of 800, 1000, 1200, 900 and 11,000. Right? And the average comes out to be 2980. When you add all these 5 and divide by 5, the average will be 2980. But can you see that the actual value of the sale in that particular shop is this only? Because you can see that first day we are at 800, then we were at 1000, then we were at 1200, then we were at 900. Suddenly one outlier value came and it changed the entire average, right? The average value is right, but is it actually representing the sales of every day for that particular shop? The answer is no. Why? Because mean is sensitive to, or there is sensitivity in mean towards outliers. So high value like 11,000 inflates the average sales. Okay. So what is the problem over here? Just one outlier killed the entire game. So you have to understand one very basic concept here, that when your normal probability curve is like this, is a normal curve, the mean value is this. In this scenario, the mean value will work. But if there is an outlier value of 11,000, what will happen? It will make the entire curve go haywire and the entire mean go haywire, and your mean value will be 2980 or something else in some other case. So what you have to understand over here is that mean is sum of all the values, right? And then it represents the central balance point of the data until the data is normally distributed and not right or left skewed. Okay, so if your data has any kind of outlier, I would not recommend you to use the mean, right? So if you report that your average sale is 2980, you are overestimating your regular performance, correct? Hence you have to be very sensitive towards outlier while using mean, correct? I hope you understand the point over here. Now let's move to the next one, which is nothing but another concept, median. Okay, now median is the middle value where data is ordered. Okay, just imagine if you want a measure that is not fooled by outliers or extreme values, then what you will use? You will use median. Let's take the previous example here. Okay, let's take the previous example here where the sales were 800, 900, 1000, 1200 and 11,000. What is the median? Means middle value. What is the middle value? The middle value is 2 here and 2 there, so the middle value is 1000. So can you say that your average sales per day is 1000? It looks realistic, right? Because with the help of mean, we were able to deduce the average sale is 2980, which was extremely far-fetched than the real sales of every day. But when we use median, we saw that this 1000 gave us a very close or clear picture about the average sales of the shop, right? So median is the middle value when data is ordered in which way? Incremental way, correct? Now just take this one example. As I said earlier, the median is 1000. So what we learned over here, that median is not affected by extreme values or outliers. Unlike mean, median remains stable despite large outliers. Okay, let's take a real life analogy over here. Median income better reflects typical earning than the mean, like we see over here also, correct? Now let me just clear it out quickly for you and give you another example, correct? So in a company, or maybe in a class, let's not go to the company, let's go to a class only. Average marks of the students in math is 50, 55, 61, 35, 52, 62, average, right? And one student have scored 99. Don't you think that the overall average will be pulled and the overall score might come in the range of 70 plus minus, right? Is it the real representation? Because most of the people have got close to 60 or less than 60. One has got 35 also. This is also an outlier. This is also an outlier. But most of the class is near in the range of 50 to 60. Correct? So what we have to understand over here, that whenever there is a outlier, I can say extreme value, mean is not very powerful. But when you don't have any kind of extreme outlier in your values, definitely mean is the right way. So what we understand, when there is an outlier, median is the right thing. When the data is normally distributed, mean is the right thing. Okay, I hope you understand this concept, and let's move to the next slide. What is the third thing which we want to understand today? Mode. So what you want to master today? Mode. So mode is the most common value in your data set, one that occurs most frequently. Correct? Now let's see with an example, with this example. Let's see with this example. So what example we have over here? The average test score is 85, 90, 85, 70, 95. Which value has occurred the most? 85 and 85. So what is the mode over here? 85. As the definition says, most common value in your data set, the one that occurs most frequently is basically the mode. Let's take another example over here. Most common shoe size. The shoe size which is most common in India, US, UK, Middle East, Europe, anywhere, it is deduced by the logic called mode. Or second, the OTT genre. What is the most loved OTT genre? What is the most watched Tom Cruise movie? I think it is Mission Impossible, right? And what genre it belongs to? It belongs to action genre. So maximum time, or most of the time, people have seen Tom Cruise in which movies? Action movies. Though I like him in a chocolate, he looks like a chocolatey hero, right? He looks like a romantic hero, but most of his movies have done a greater business while he has done action movies. Correct? So let's take another example also. What is the color preference? Red, blue, green, red. So what is the mode? Red. So mode applies to both numerical and non-numerical. Non-numerical means categorical data, right? So just imagine we have three genders in the population: male, female, and transgender. So just imagine if we have a sample population of 1,000, male comes near about 45 times, female comes near about 40 times, and transgender comes near about 15 times. So what will be the mode over here? 45. I have written the total, but when you write like this, M 45 times, female 40 times, and transgender 1 time, you will understand that the most common occurrence is male, or maybe female, or maybe transgender. Here I have written 45 for male, so I told you that the mode over here is male. Correct? So it applies on categorical data as well as it applies on numerical data. So when I applied it on male, female, and transgender, that is something which I talked about, the categorical data. So I hope you understand mean, median, and mode in a very simpler way. Now let's understand the bell curves and the skewness, right? This slide might take some time because I have to make you understand how the distribution looks like. So for a normal distribution looks like this: equal at this side, equal at left side, equal at right side, and the mean is near about this. Correct? Population is equally divided towards both the sides. It represents balanced data where mean is equal to median is equal to mode. So just imagine anything which comes here. So mean and median and mode all will be same. Correct? Because the data is normally distributed, right? Just imagine the height of a person starting from 0 to 6 feet. So what will happen? The mean or the median or the mode will come to here. Correct? So it is a normally distributed data, and here everything happens in a very simple way. Now just take the right skewed distribution. This we talked about the normal distribution. Let's see about the right skewed distribution. Okay, so the right skewed distribution looks like this, right? It is not normally distributed. Why it looks like this? Tell me. It's a very simple thing. Let's take example of income in the entire world. Do you think that income in the entire world has a normal distribution? I would say no. I'm taking example of India because we are recording the video from India only. So if the income starts from 0 to 1 CR per annum, I'm taking hypothetical value. So you'll see most of the people are lying here in this plot only, earning max to max 10 lakhs, or we can say 20 lakhs a year. But there are few people like Shah Rukh Khan and Virat Kohli, Amitabh Bachchan, Mahendra Singh Dhoni, or other Mukesh Ambani, people who are earning more than a crore per year, right? And what they are doing, they are stretching these tail from a far-fetched on the writer side. So the distribution over here is right skewed distribution. So if you see in Indian income, the distribution is right skewed, and it shows that mean is greater than median greater than mode, while in the normal distribution mean is equals to median is equals to mode, right? So due to data tailing right, highlighting income inequality comes to the right skewed distribution, right? So most of the people sits here in the entire India. Most of, I can say 80 to 90% people, or maybe 95% people reside over here only, but 5% population is here who's holding more than crore rupees of wealth per year, and that is making this entire distribution rightly skewed, right? I hope you understand. Now let's take a left skewed distribution, and we will see, take the retirement age over here, right? How the left skewed distribution look like. When you create this, the left skewed distribution looks like this. In India, the retirement age is 60. So if you start from 0 and take it 80, most people retire here, 60. Few people retire here also, few retire here also, and few might quit their job and go to pursue their own hobby. But most of the people retires here only. When I say most of the people, mode comes to the picture. When I say most of the people, modes come to the picture, and then mode is greater than median is greater than mean, right? Indicating data tailing left with earlier common values. Okay, let's repeat once again. In normal distribution, mean is equal to median is equal to mode, because the central tendency is here. The overall data sits here, the median sits here only because of normally distributed data. Here, the mean is higher because it will take the entire average to a next level. People earning 20 lakh and people earning 10 lakh, 2 lakh, 3 lakh gets highly affected by people earning 1 crore. So in the right skewed distribution, mean plays a very big picture. In the left skewed distribution, where the bulk of the population sits here only, and most of the population sits here only, when I say most, then mode comes to the picture, and mode is greater than median than mean, right? So what is the key takeaway? Always verify the shape of your data before summarizing with the mean to avoid misleading conclusion, because generally people take right normal distribution and start giving the conclusion based on that only, where even if you don't have the right understanding about the skewness of the data or distribution of your data, and you are giving them take mean, take median, take mode without even thinking of the skewness or distribution of the data, you will do false calculation, right? I hope I made myself very clear. It's a very important slide, guys. If you miss this, if you skip this, you will fall into the trap, right? So never ever give the conclusion without understanding the distribution or skewness of the data. Okay, now let's move to the next slide, where I'll explain what to use when. It is a very important slide for you, and you have to focus here extremely dedicatedly, right? So when the data is with outlier, the data is without outlier, as I say, it's represent to average because normally distributed data. What you will do, you will use mean. Data without outlier, without even thinking, you can use mean. When the data is with outliers, there are many outliers, use median because it is not affected by extremes. It choose the median value. When you have the categorical data like male, female, transgender, India, Pakistan, US, America, or I would say 3 BHK, 2 BHK, 1 BHK, sedan car or hatchback or SUV or in any kind of category, color, red, blue, green, white, you can take categorical data and you can take mode because it works with labels. Labels mean this person is female, this person is male, this person is transgender, he loves SUV, he loves hatchback, he loves sedan, he loves small cars, all those things. And when you have multi-model data, you can use mode again, or you can say modes, because it can have multiple peaks, right? So this slide is I would say a cheat code for you, a cheat slide for you, where you can see and understand. Whenever you are confused, you don't have to go to the entire video once again, that what to use when. You can just easily see this slide and make yourself comfortable what to use, what not to use, and what to use when. Okay, now let's I hope I made myself very clear. So let's move to the business side. Okay, so in banking, what happens in banking? I don't think I need to write a lot over here, but still I'll make a tick mark for you to understand where I am at and in the slide. So in banking, to decide credit limit, bank use median income of a region to avoid extreme rich or poor bias. So just imagine in Mumbai, Kolkata, Delhi, Chennai, and any other city or region, what does bank do? Bank take median income of a region so that the credit limit is set, and they avoid bias for extremes, because in every state there are rich people, there are extremely poor people, and banks worked for most of the population. So what they do, they take median income. In retail, what is retail? Retail means selling any kind of item. They use mode. Why? Because it is the most occurring or most selling item. When the word most comes, you will use mode. So mode identifies most sold product size. So every retail shop or retail business, they use mode. In education, again, mean marks for overall class performance, median for typical student, and mode for most common grade. Okay, and in health, mean patient age and median recovery time helps resource allocation. Let's move once again and recap it very quickly. So bank use median income. Median avoids any kind of outlier. It does not use mean, it use median, very simple. So they don't affect by the outliers, by poor or by rich, and they focus on the middle class people to give them loan or give them a credit limit, right? In retail, mode is the most identified, I would say, way or measure to understand which product is selling the most, because the most word came over here. In education, mean means the overall class performance, median is for a typical student, that let's see what happens if there is an outlier, and then mode is for most common grade. So grade are A, B, C, and D. If the most common grade is A, the class will say, or the school will say, we have a lot of A graders in our class, okay, or in our school. And in health, mean patient age is important because they see that in a hospital, what is the mean patient age. Generally, what happens that in hospital, all kind of people come, so the skewness goes away with mean and then median they take for the recovery time, that because older people take larger time, or say more time to recover, and the younger people take lesser time, so they take median, because within the I would say, when the population of younger and older people, what happens? The timeline differs a lot. So they take median to understand the recovery point. Okay. So I hope you understand the key average driver over here, how to unlock business insight using mean, median, and mode, and it will definitely help you, right? What we can do, we can move to the next slide, and we'll see that what we have in store. So I think the theory part is over, and you have to do some hands-on practice and understand the pitfalls of it, right? So these are the four things for you. You can use it on Python, and in our detailed course, which we'll launch very soon, we'll have all the hands-on exercises, but to make you understand what you have to do, what you don't have to do, we have written down 4 points. So example is the data set is 10, 20, 20, 30, 40, 50, 70. Use your Python file and try to calculate the mean. Mean is calculated as 240 is divided by 7, so it is equal to 34.3. Median, so let me write something so that you can understand. So when you take mean of this value, the mean will be 34.3. When you take median, the median will be 30. When you take mode 1, 2. Most occurrence is 2, so the mode is 20, right? So the mean is 34.3, median is 30, and mode is 20. Why 30? Because it is the middle value. Why 20? Because mode 20 comes 2 times, right? You have to choose the best measure. As I told you, right skewed and left skewed data, you have to understand it correctly before giving the answer. That you need to see that the data is normally distributed, or the data is right skewed, or the data is left skewed. Right skewed means the right tail is very high, left skewed means the left tail is very high, right? So what is the common beginner mistake? Reporting the common beginner mistake is they reporting mean despite presence of outliers, right? I told you that when outlier is there, don't report mean, report median generally. Forgetting to sort data before finding median. Okay, so as I said, you have to order, you need to order it. Just imagine if you have 10, 20, 10, 5, 20, 30. What is the mean? And 40. What is the median value over here? 5. Do you think it is the average? No, you have to sort it before giving the median. So how you'll sort it? 5, 10, 10, 20, 30, and 40. Then you can, I think 20 is 2 times, 20, 20. Then what is the median value? This is the median value. And when you say, okay, 20 is the median value, it gives you the right picture. If you don't sort the data before giving median, what will happen? It will find the wrong value. When you'll sort it in the ascending order, it will find the right median for you, right? Also, the third mistake is people always assume mode, that they assuming that mode always exit in the dataset. It is not the right way, because sometimes only choosing the mode without understanding the dataset will give you wrong picture, correct? And ignoring data shape and skewness, I told you. So what is the pro tip? Always visualize your data first with a histogram before choosing a measure. So by using histogram, you can easily plot the data and can see the distribution and skewness of the data, and based on that you can choose the right measure, which can be mean, median, or mode, right? Let's move to the last slide of our lecture today. So it is a repetitive measure which we are saying, but it will be very important to give you a very core understanding that what we are trying to achieve over here. Okay, so as I say, mean tells the mathematical center. Okay, it's average, it tells you the mathematical center. It is extremely sensitive to outliers. Never use mean if you have outliers in your data. Median gives the middle real world value, right? So if you have 1, 2, 3, 4, 5 data points in ascending order, this will come as a median, and even if this value is outlier or this value is outlier, the median will give you real middle picture, right? Mode identifies the most common value. Again, if you have 5 colors, red, I would say blue, white, and green, your mode is red, means most of the time red color is selected. So if your shoe size is 7, 7, 8, 7, 9, the shopkeeper understand that in my shop people are coming to buy shoe size of 7. In this particular reason, the shoe size is 7. Mostly the shoe size is 7. And knowing when to use each measure distinguish good analysts from great ones. You all will be good analysts after watching this video, but if you repeat and keep on repeating these videos and videos like this and understanding when to use what, using the skewness and the distribution of the data, you will become a great data analyst, right? So what we will do in next video, we will understand the measure of spread, range, variance, standard deviation, all those things. Maybe we'll add some more topics in that slide, or maybe we'll skip this and understand the basic concept first. But right now I'm thinking that we'll go ahead with range, variance, and standard deviation. So how we'll close this? If this helps simplify statistic for you, please hit like and subscribe our channel, because your data science journey is beginning right now with us, and we'll make sure that we'll make you understand the core concepts in a very simple manner. Whatever complexity is, we are here to solve it for you. Very soon we'll start to launch our own classes in a very cheap rates, which you can not only absorb but can store it for your future use. With this, I'll give a pause to myself, and a very thanks to you for attending this session, and have a good day. I'll see you in the next class.